I'm going to give you a bunch of information today. And we're going to make some graphic organizers about this. So let me zoom this out just a little bit. You can think of this as being in 4.2, but there's also a little bit from like 4.7, 4.8. So if you're looking at a specific section, 4.2 is going to be where we're going to start from. Now, before you start writing this, is in any triangle ABC, where the triangle looks like this. Well, it doesn't have to look like this. It can look, yeah. But just give it a second here. In any triangle ABC, capital A, capital B, and capital C are your vertices, which means they're the name of the angles. But we're also going to throw in a little bit with some sides in it. So I'm just going to throw, like I said, a bunch of different things at you. Now, the first thing we're going to talk about are the interior angles. So this is angle A, angle B, and angle C. So what I'm talking about with these guys are, here's angle A, here's angle B, and here's angle C. And so what we're doing is what we call an advanced organizer, where I give you all the information right up front, and then we always refer back to it. So honestly, I'm not expecting you to understand everything right off the bat, but I'm giving you a bunch of information that you need to put in your notebook so it's there, so we can always go back and take a look at it. So if we're dealing with the interior angles, there's a theorem. It's called the triangle sum theorem. Now remember, with a theorem like this, do we accept it as true, or can we prove it? We can prove it, and I can actually prove it for you. I'm not going to prove it for you today, but we could prove it if we needed to. The triangle sum theorem talks about what happens when when we add all three angles. Anybody remember this? If I added the measure of angle A plus the measure of angle B plus the measure of angle C, add up all of these together. What was that? No, it's not the perimeter. We're going to get a number. And it's going to be one of our special numbers. The special angle values. What two angle values that I already said that are special? 90 and 180 degrees. So, which one do you think it is? 90 degrees or 180 degrees? 180 degrees. So it's 180 degrees. This is something that you need to commit to memory. So we get the triangle sum theorem from here. Now, I'm going to kind of move this up a little bit so we can see first. Where's my blue highlighter? Ugh. So that's something that you need to know, and we'll talk a lot about that. But there are some corollaries from this. And corollaries are, let me zoom in on here. You can think of corollaries are things that happen because of the triangle sum theorem. And there's going to be two of them. One for right triangles and
Please excuse this interruption. I need all freshmen with the last name beginning letters A through C. Please report at this time to the reference library. That's freshmen last names beginning with the letters A through C. Please report to the reference library at this time.
all right. Now, for right triangles and for equal angular triangles. And these have to do with the fact that, all right, if you add up all the angles, you get 180 degrees. Now, for a right angle, if we have this, freshman. Now, if I add up all these angles, what do I get? Not all of them. If I go x plus y plus, what's this angle? 90, that's equal to 180 degrees. If I subtract 90, x plus y is equal to how much? What's 180 minus 90? 90. And this is the corollary for right triangles. The two angles that's a horrible A. The two acute angles in a right triangle add to 90 degrees. Or you could say they're complementary. And that's just from the triangle sum theorem. X plus y plus 90 is equal to 180. That's your triangle sum theorem. And the corollary says, because the triangle sum theorem works, then we find out that no matter what x and y are, they're always going to have to be 90. So it's kind of like a consequence of it. It's like if you have a curfew at 10 o'clock and you stay out to 4 o'clock in the morning, what's going to happen? Probably get a whooping, right? Well, back in the old days you would have. But now you probably would have got yelled at and then sent to bed. That's a consequence of missing that. So there's like a consequence of things happening. Now, equal angular angles, or triangles. What do we know about all the angles in the triangle? They're all the same. So if I go x plus x plus x, x plus x plus x is how much? 180. How many x's are there? So we got 3x is equal to 180. Divide by 3, divide by 3. What's x equal to? 60. So in equal angular triangles, all angles are 60 degrees. So you need to know that. This is the begin. What we're doing is we're going to examine everything about the angles and everything about the sides and all the relationships. This is a huge part of it. This is kind of like the framework. If you don't understand this stuff, everything else is going to be really, really tough. All right, now, are we okay with that? All right.
So what would you say was interior angles?
Yeah, that was all the inside angles. Now, I know yellow highlighter on yellow paper really doesn't work all that well, but I have a triangle here, and I'll say that's A, B, C. Now, this line right here is called an auxiliary line. Or you could call it an auxiliary segment. And what we do is we take one side and extend it. And then what we create here is what we call an exterior angle. And this angle right here and this angle right here, we're going to call these the remote interior angles. And we call them the remote interior angles because they are the two angles farthest from the exterior angle or we could call them the two angles that are not adjacent. Now, what does adjacent mean again? Right next to each other. So they're the two angles that are not adjacent to the exterior angle. This guy right here, that's the angle that's the exterior angle, or the adjacent angle to the exterior angle. So what I'm concerned about is the relationship between this angle and these two angles that are far, far away from it. And like I said, I'm not really proving, and let me move this in just a little bit for it. I'm not really proving it yet, because I can prove it. But here's the idea, that the measure of angle 1, so this is my exterior angle, that's going to be equal to, I take these two angles and I add them together. Measure of angle 2 plus the measure of angle 3. So the exterior angle equals the sum of the remote interior angles. And there's one last thing after this. So I'll give you a second to come up with this. And I'll... Alright, so the last bit, that's not what I wanted. The last bit that I wanted to talk about is something called the third angle theorem. And it says if two angles in a triangle are congruent to two angles in a second triangle, then the third angles in each are congruent. So if that's A, B, C, and that's D, E, and F. So if I know that these two angles are congruent and these two angles are congruent. So if angle C is congruent to angle E, so that's one angle, and angle B is congruent to angle D, so these are two angles in one triangle and two angles in a second triangle, then what two angles have to be congruent to each other? Which was that? Yeah, then angle A has to be congruent to angle F.